Alright, so we are going to try a version of the flipped classroom, and if you don't know what the flipped classroom is, it's essentially where you can learn the content via video or PowerPoint or something that your teacher creates, and you would typically learn this at home, so you could watch this video or this little PowerPoint or whatever at home, and then you actually get to do the problems and the application in school during class. And so you could ask your teacher for help, you can take notes at your own pace at home or in study hall, you can pause it, rework the problems, that kind of thing. So we are going to try this, and I know we're not truly flipping it because we're going to try watching it in class, but I didn't really know how it was going to work. So this is the first attempt at the sort of flipped classroom for geometry. So our lesson today is the sums of angle measures in polygons. So let's talk about what that means. Polygons, as you remember, poly means many sides. Poly means many, gons is sides, so many sides. And we want to know what is, for instance, a triangle. What is the sum of the three angles inside? Or maybe we want to look at a pentagon. What is the sum of the 5 angles inside? So that's what we're going to try to look at today. The first thing that we want to look at is a theorem, and again you can look this up in your Coral packet. It's also in your textbook, but it is called the triangle sum theorem. So this one's specifically for triangles, not all polygons. And what this is the sum of the angles in a triangle is 180 degrees, which most of us probably already knew that. Okay, so that's pretty simple. And again, this just means if we have angle A, B, and C, A plus B plus C equals 180 degrees. Okay, so let's try some practice with where maybe we would use this. Okay, so for instance, let's say we have a triangle. We know information about our 3 angles, and we want to know what the measures of all 3 angles are. How do you think you could go about finding that? Alright, so take a moment, pause the video, see if you could find the value of all 3 angles. Hopefully you set up an equation, something like this. We could combine all of our x's, and we would get x is 30. So up in our triangle we could plug in x is 30 for all of our x's. So this one would end up being 30 degrees. Here we would have 90 degrees, pretty close. And here we would have 60 degrees. You could always double check your work. Does 90, 60, and 30 add up to a total of 180? It sure does, so we know we are correct. The next theorem that we want to look at is the quadrilateral sum theorem. And just like the triangle sum theorem, it tells us exactly how many degrees are on the inside of a quadrilateral. So we can have a parallelogram type, or a square, rectangle, etc. But again, we're looking, what is the sum of these 4 angles? And this says the total of the 4 angles of a quadrilateral always equals 360 degrees. So we could solve similar problems as we did with the triangle, knowing that if we add up all of the angles inside, it's going to be a total of 360 degrees. So think about this. We have a theorem for triangle sum. We have a theorem for quadrilateral sums. Do you want to memorize or have a theorem for every single polygon? Of course not. Okay? It would be a lot to memorize, and there's an infinite number of polygons, so let's come up with a better way than learning a theorem for every single quadrilateral. To come up with a way to find the angle measures of any polygon, let's look at what we already know. Okay? So we're going to look at how many sides our polygon has. We're going to look at the number of triangles in that polygon. And then we're going to look at the sum of all the angles. And hopefully we're going to come up with a formula, an expression that will help us find any sum of any polygon. Okay, so let's start with our triangle. Okay, we have a triangle. How many triangles are there in a triangle? Okay, there's one triangle. And we know that the sum of the angles in one triangle is 180 degrees. Okay, so let's look at our quadrilateral. We have 4 sides. So again, any old quadrilateral will do. How many triangles are in a quadrilateral? Regardless of how you split your quadrilateral, if you do it like this, or if you do it like this, there's 2 triangles here. If we know that every triangle is 180 degrees, we could take 180 times our 2 triangles, we get 360. So that's where our 360 came from in our quadrilateral sum theorem. Okay, so let's think about 5, a pentagon. How many triangles are there in a pentagon? Again, split it however you want. We have 3 triangles. So again, we could do 180 times 3. And what is 180 times 3? Figure that out. 540. So if we wanted to come up with a pentagon sum theorem, we would say that it has 540 degrees. But this is why we can come up with all of those measures. Okay, so moving on. We're trying to find a way, an easy way, to come up with, let's say, how many, or what is the angle sum of a 10-sided polygon. Okay, so let's try drawing a 10-sided polygon. It doesn't have to be pretty. Definitely not very pretty. How many triangles can we get out of a 10-sided polygon? 1, 2, 3, 4, 5, 6, 7, and 8. So there would be a total of 8 triangles in a 10-sided polygon. Okay? Well, we could use the same formula we had on the last page. Okay? So we have 180 for every triangle we have. In this case, we have 8. And we could figure out that 180 times 8 is 1,440 degrees. 40 degrees. Okay? Again, if I wanted to find what's the interior angle sum of a 25-sided figure, do you want to go through and draw a 25-sided figure draw all of your triangles, count them up, multiply it by 180 just to get your degree measure. Of course not. So, what I want you to do is go back and look at this page. Maybe calculate a couple more, maybe calculate 6 and 7-sided polygons, and see if you can come up with a formula, an expression that would allow us to just plug in information rather than drawing the shape, splitting it into triangles, and multiplying it by 180. Okay? So pause the video, take a few minutes, see if you can find the pattern. Okay? So in other words, if I have 3 sides, I have 180 degrees. 4 sides, that's 2 triangles, so 360. 5 sides, so 3 triangles, so 540. What is the pattern? Okay, so hopefully you've found a pattern. So again, let's recap. If we had 3 sides, we have 1 triangle times the 180 degrees. If we had 4 sides, we had 2 triangles times the 180 degrees. If we had 5 sides, we had 3 triangles times 180 degrees. 6 sides, hopefully you went ahead and tried this. You have 4 triangles times 180 degrees. 7, we ended up with 5 triangles times 180 degrees. If you noticed, 3 sides, 1 triangle. 4 sides, 2 triangle. 5 sides, 3 triangles. So on and so forth. So our number of sides, which we could just call n, we were always left with 2 less triangles. And then we multiplied that by 180. So hopefully the formula that you came up with was number of sides minus 2 times 180 degrees will always give us the total sum of the angles inside any polygon. Okay? Which moves us to our next theorem, which is called the polygon sum theorem. And what this says is the sum of angles in a polygon with n sides, so we could plug in anything for n, is given by that n minus 2 times 180 degrees. So we could put in anything. We could put 25 in there. Okay, so let's say we wanted to know the sum of the angles in a 25-sided figure. We're not going to draw that and cut it into triangles. We're just going to put 25 in for n. So we get 23 times 180. 23 times 180 is 4,140. Okay? So to recap really quick, what this lesson was about is how many degrees are in a polygon. Doesn't matter what our polygon is. We now know a way to find the sum of all of those angles. We can just plug it into this formula. Again, n being the number of sides we started with, and you can go from there.